A warm welcome to everyone. Myself, Tanya S. from the Department of Computer Science and Engineering, Artificial Intelligence. I am from Sri Venkateshwara College of Engineering, Bengaluru. So today's subject is about chemistry. Topic is batteries. Contents are basic components of batteries, classification of batteries. First one, basic components of batteries. A battery is made up of anode and cathode, which are surrounded by their electrolytes. The anode and cathode are separated by a separator. The outer surface of the battery is covered by a plastic layer, and in modern batteries, the ventilator also provided to escape the accumulated gases during process. So a battery is made up of anode and cathode, where they are surrounded by electrolytes. So these anode and cathode are separated by a separator. So the outer surface of the battery is covered by a plastic layer, but in modern days, ventilator is provided for them. So battery consists of four major components, that is anode, cathode, electrolyte and separator. So as you can see in this picture, you can see the left one is anode and the right one is a cathode. Here it is an electrolyte, and this this separator, this is known as separator, and the upper one is called as ventilator. Next one, major components of battery. Anode. In a battery, anode is negative electrode. It releases electrons into external circuit by undergoing oxidation reaction. In rechargeable battery, it acts as positive terminal, cathode. During charging, it gives the electrons to an external circuit. So in anode, it is actually a negative electrode. So it releases the electrons into the external circuit by undergoing oxidation reaction. So during the charging, it is cathode and it gives electrons to external circuit. This is the reaction of that. M gives rise to Mn plus plus Ne. So zinc, lithium, nickel, cadmium and lead are extensively used as anodes. So next one is cathode. In a battery, cathode is a positive electrode. It accepts the electrons from the external circuit. Thereby, reduction of the active species occurs. In rechargeable battery, it acts as negative terminal called anode during charging. So cathode is actually a positive electrode where it accepts the electrons from the anode. So these are the in rechargeable battery, it acts as negative terminal, anode. So during charging. So the reaction is Mn plus Ne minus gives rise to M. So this is the opposite of anode. So graphite rod, zinc, lead, nickel and cadmium are used as cathodes. Sometimes both anode and cathode are made up of same material like lead, as in the case of lead acid battery. Next one, electrolyte. It provides the medium for transfer of ions inside the cell between the anode and cathode. A solution of an acid, alkali or a salt having high ionic conductivity is commonly used as an electrolyte. So electrolytes is a medium of transfer ions between between anode and cathode. So the solution which is having acid, alkali or salt is having high ionic conductivity is commonly used as electrolyte. Next one is separator. It is used to separate anode and cathode compartments in a battery to prevent internal short circuiting. So without this separator, we cannot able to separate anode and cathode, which may be dangerous by occurring an internal short circuit. The main function of this separator is to transport ions from anode and cathode, and it is vice versa. So it is highly resistant towards electrolyte. Examples are cellulose, vinyl polymer, polyolefin members, etc. Next topic, classification of batteries. So batteries are classified into three types, where there are primary batteries. It is known as non-rechargeable batteries. Secondary batteries, rechargeable batteries also known as. And the third one is reserve batteries. Firstly, we know about the primary batteries. The batteries which produce electrical energy at the expense of free energy of active materials and produce energy only as long as active materials are present. So in this primary battery, the batteries which produce electrical energy at the expense of free energy of active materials. So they are only produced when the free energy is available, and the energy only stays as long as active materials are present. Examples are ZnMnO2 battery, LiMnO2 battery, etc. So in these batteries, the reaction is spontaneous but irreversible. These batteries have a higher capacity and initial voltage than rechargeable batteries. Second one is secondary battery. The batteries which produce electrical energy at expense of free energy of active materials. These active materials are capable of restoring at respective electrodes and recharge and prepare for discharge once again. So in secondary batteries, so they can produce electrical energy as expense of free energy of active materials only. So these active materials are capable of restoring the energy again and again. And I mean, it can be used again and again. So it can be restorable. So in these batteries, the reaction is reversible. So in primary batteries, it is irreversible. The examples are lead acid battery, nickel cadmium battery, etc. So last one is reserve battery. These are the batteries which may be stored in inactive state and are made up activated just before they are needed. The activation involving by adding electrolyte, because one component of electrolyte is isolated and stored separately when the battery is required. So in reserve batteries, they may be stored in inactive state and it is made activated just before they are needed. I mean, they need to be activated. So the activation involving by adding electrolyte, it is because of one of the component of the electrolyte is isolated and stored separately when the battery is required. So the examples are MgH2O activated battery, ZnAg2O battery, LiV2O5 battery, etc. Thank you for this wonderful opportunity. Thank you, everyone.